Welcome, geometry students, to a Kuta worksheet tutorial. We're going to be doing coordinate plane proofs. So this is actually a really good section because it goes over a variety of topics that you probably have covered throughout the whole year. This is going to be a longer video. I'm guessing I'm going to have to split it up into two parts, but this worksheet is excellent. So I just thought I'd go ahead and show you guys this. We're going to start with number one. It says plot -5, 6, 3, 7, 4, 1, 4, -1, -4, and -2. So we're going to go ahead and plot that real quick. So we got -5, 6, 3, 7, 4, -1, and -4, -2. Okay, just double check that. 4, -1, 3, 7, -5, 6. Okay, so we're asked to connect these dots, and it's going to form a quadrilateral four-sided shape. So it should look something, it should look something like this when we're all done with it. I hate it when it does that. Okay. And there we go. Okay. Interesting shape. All right. So the first thing it says is prove that ABCD is a parallelogram by showing opposite sides are congruent. Now, in order to find that opposite sides are congruent, we need to know that they are the same distance or equal distance. You can use the distance formula here. So the distance formula is equal to the square root of x2 minus x1, the difference in your x coordinates squared plus the difference in your y coordinates squared, and that is the distance formula, okay? Or you can use Pythagorean theorem. This is my preferred method, especially when you have it drawn on the coordinate plane already, where c squared is your hypotenuse. In this case, it'd be the side that you're looking for. Just so you get an idea, I'm going to show you the distance formula first, and then I'm going to show you Pythagorean theorem. And then you guys can decide for yourself which you prefer. I just think, for the sake of a video, Pythagorean theorem is a little bit quicker, so I'll probably be doing that for most of the video. But I want to show you distance formula. Okay, so this is the point -5, 6, and this is the point 3, 7. So the first thing you got to do is you got to label it. If you remember back to distance formula, you have to label these points. And then what we're going to do is we're going to plug it right into our distance formula. That is equal to your difference in x's. So I'm going to do x2 minus x1 minus the -5. Make sure you include the negative in parentheses, plus, and then we have 7 minus 6. Quantity squared. Now we're just simplifying from here. So we have square root of 3 minus negative is plus, so that's 8 squared, plus that's going to be 1 squared. So we have the square root of 64 plus 1 equals the square root of 65. Now, since we're just trying to see if they're congruent, we don't need to simplify this any further. I can make another video for simplifying square roots a little bit later on, but we just need to know if all these other sides are also square root of 65. Okay, so that being said, let's go ahead and take a look at the next side. So we took a look at this side. Now we're going to take a look at this next side. And you can pick any. I'm just deciding to go with this blue side right here. Let me make that a little straighter. Something, oh my gosh. I'm not sure what's going on. Okay. So, in order to use Pythagorean theorem, what I like to do is I like to make two sides of a right triangle. And it's important that it's a right triangle because a right triangle, you can use, that's the only time you can use Pythagorean theorem. So I have this blue side, I have this pink side, and I have this yellow side. What I do now is I just count the distance of each of those legs. So we have one, let me get my pointer out. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is a distance of 8 for that leg. And then we have a distance of 1 for that leg. Okay, so now we're going to use Pythagorean theorem, which says a squared plus b squared equals, this is our highlighted side, our hypotenuse, so to speak, equals c squared. So we know that c squared is going to be equal to 1 squared plus 8 squared. Well, it's essentially the same thing we just did. We know this was equal to 1. We know this was equal to 64 equals c squared. We got 65 equals c squared. And we'd have to take the square root of both sides, and we get c equals the square root of 65. We got the same thing as we did last time. This is a good sign because now we're off to a good start with, oh, I should have chose the opposite side. Well, anyway, I chose this side. But anyway, we know that this is square root of 65. We know this is square root of 65. So now we just need to see the opposite sides, which are those two. Sorry, I should have chose the opposite side. So let's go ahead and do that. And to do that, I'm going to use the same process, which is I'm going to choose 1, 2. I am creating right triangles, and you're going to use Pythagorean theorem. 1, 2, 3, 4, 5, 6, 7, 8. So I have, did I write the coordinates down correctly? So we had 4. Oh, no wonder. This side was marked incorrect. No one said anything. Unbelievable. So this was supposed to be -4, -2, not -3. This shape looks a little bit better. I was going to say, it doesn't look like opposite sides are going to be congruent. Okay, there we go. So as you can see here, we're getting a same 1, 2, 3, 4, 5, 6, 7, 8. We got another 8 by 1. And if you want, you can go ahead and plug this into the Pythagorean theorem. But hopefully you realize that if you use the Pythagorean theorem with the same numbers, you're going to get the same answer. You're going to get square root of 65. So you can see that these two opposite sides are congruent. Okay? And then if we go to this last one, you're going to see that we don't have to use it again. 3, 4, 5, 6, 7, 8, and 1. Again, same legs of a triangle because they're congruent for side angle side. They're all three of these are right triangles with the same leg measurements. So it is congruent. They're by corresponding parts of congruent triangles, they're going to be congruent hypotenuses, and it's going to be square root of 65. So actually, not only are opposite sides congruent, but all sides are congruent. So we just proved that opposite sides are congruent. It is a parallelogram because that's the definition of a parallelogram. Now we want to prove that ABCD is a parallelogram by showing opposite sides are parallel. Okay, great. We need to know here, if it's parallel, we're talking about equal slopes. Sides are congruent, equal distance. Sides are parallel, equal slope. So we need to know what slope is equal to. Slope is equal to the rise over the run, or more mathematically, y2 minus y1 over x2 minus x1. A way to remember it is you rise with the y's, and you run from your x's. Okay? Now, luckily for this first side here, this one right here, we already had the points labeled, okay? So we can easily find the slope here. I'll go ahead and use this like darker blue. So we can find the slope of this first side, which was, I didn't label it. I should have labeled A, B, C, D, but you guys understand it, I think. But anyway, we're going to find the slope between those 2 points, okay? So our y2 is 7. Our y1 is 6. I'm just using this formula over here. y2 minus y1, x2 minus x1, okay? Just in case you're wondering. So 7 minus 6, and then I'm going to do 3 minus -5. 3 minus -5. 7 minus 6 is 1. 3 minus -5 is 8. So I have a slope of 1/8. That means I go up 1 unit. For every 8 units, I go to the right. Okay? Now, if I want to find the slope, let me get my little eraser here. If I want to find the slope of this side, I can do the same process. I could label the points, okay? x1, y1, x2, y2, okay? That's kind of like the long way to do it. The easiest way to do it, in my opinion, is to just count. So let me show you what that looks like. First, I'm just kind of getting rid of some of this extra stuff we don't necessarily need right now. So if you want to like go back and reference it, feel free to do so, but I'm erasing it just to make it a little bit more clean. Okay. Okay, so if we're looking here at our slope of this one, the easiest way to do it, in my opinion, is just to count your rise over your run. So these are the 2 points we're considering. Boom, boom. We need to go up 1, and then we're even with it. Okay, so up 1, where you're even with it. Now we need to go to the right. So to the right, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we arrived exactly at the other point. So again, our slope here of this line was this between D and C or something like that. We got up 1 over 8. Up 1 to the right 8. Notice how we have the same slope. Okay, so our slopes were the same. What does that mean? Well, same slope means that they're parallel. So these are the same. Therefore, they are parallel slopes. Okay, so we got one set of opposite sides, showing opposite sides parallel, but we still have these ones to do. So these 2 sides over here. So let me get rid of some of this information, okay, that we don't need at the moment. Okay, and now we're going to be, let me get rid of this too. Okay, now we're going to do these 2 sides. So we're going to do this side and this side to see if they're parallel. So I'm going to do that real quickly. Okay, let's do that in yellow, all the same color. So I'm going to start at this point, and I'm going to go down to this point for this side, okay, just so you know. So I go, first you always go vertical. So how do I get vertically from this point to this point? Well, I need to go down. That's 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8. Slope. I went down 8. So I went in the negative direction 8 units. Then I go to the right 1 unit. So that's positive 1 unit. So my slope is negative 8 over 1 or just negative 8. Now I need to compare it to this side. How does this side compare? Well, from this point, I always like starting on the left point and then moving to the right, just like I read left to right. So I go down 1, 2, 3, 4, 5, 6, 7, 8. Now I'm even with it, and I go over 1 unit. So again, I got slope equals negative 8 over 1. I went down 8 over 1. Well, what does that mean? It means that these 2 slopes are parallel. So negative 8, whoops, I wanted to make it so it highlights, not gets rid of it. Negative 8, negative 8, okay? That means these slopes are parallel. So again, opposite sides are parallel here. Guess what we can add? We can add these little things, these little carets, which means it is parallel. And we also know they're congruent, because we already proved that. So we proved opposite sides are parallel. That is excellent, okay? We had the sides slope equals negative 8. We had another slope negative 8, okay? Opposite sides parallel because the slopes are the same. It's done with step 2. Now, prove ABCD is a rectangle by showing that it has 4 right angles. Okay, how do you do right angles? Well, we can't measure the degrees basically with like a protractor or anything like that, but we can show if something has a perpendicular relationship. A perpendicular relationship is shown with slope. So we can show something is perpendicular if slopes are opposite reciprocals. Okay, so if we want to show something's perpendicular, we need to consider which sides we're talking about. So let's say we're considering this side and this side, and we want to know they're perpendicular. Well, we already knew the slope of this first side. I'm going to change the color actually. Let me go this purple color. Okay, we already know the slope of this side was 1 over 8. So the slope was equal to 1 over 8. We knew the slope of this next side, okay, the side touching it, so we can figure out what this angle is. This angle right here, we want to know what that angle is. We know the slope of this purple side was negative 8 over 1. We just showed that over here, remember? Negative 8 over 1. Now, what kind of relationship do these two have? Well, one is 1 over 8. The other is negative 8 over 1. How do these compare? Well, these are opposite reciprocals. It went from positive to negative, and then we had the denominator became the numerator, and the numerator became the denominator. Okay, that is the definition of opposite reciprocal slopes. Therefore, these are perpendicular slopes. So these are perpendicular slopes, meaning that this, in fact, is 90 degrees. It is a right angle. As you remember, this side's still -8. Okay, this side right here, still -8. This side was 1 over 8. It was the same as the other side. So you could use a bunch of different properties to explain this, but this is also going to be 90-degree angles. All of these are 90-degree angles because they're opposite reciprocal slopes up here. Just reference these. Okay, this was -8 over 1. This was 1 over 8. And again, -8 over 1 here, opposite reciprocal there. So that means that these two lines are perpendicular. Okay, same thing with these ones, same thing with these ones. All of them are opposite reciprocal slopes. Therefore, we've proven that they have 4 right angles because perpendicular is the same thing as right angles. Now, what other name could we call this quadrilateral? How do we know? Well, we already figured out a lot of things about it. We figured out that all sides are parallel. Well, opposite sides are parallel. All the sides are congruent. Okay, so it's a parallelogram with all congruent sides. So it's either a rhombus or a square because of those facts. And then all the angles are equal. All the angles are congruent, meaning it's a rectangular square. So the only thing we said twice was square. So we can call this thing a square for these reasons. Okay, so we're done with number 1. That was a long problem. All these are long problems, but these are worth doing because it reviews all the concepts you need to understand the properties of quadrilaterals, how to do distance formula, how to do coordinate plane geometry. So I hope you found this helpful. I'm going to do a part 2 after this. If you need more help, I'm going to go faster, so make sure you reference this so you can see how I can do this faster. But thank you for watching. Hope to see you soon.